Good morning, good evening, good afternoon, good whatever time of day it is, and whatever part of the world you're at right now. Welcome back to my channel. And today we're gonna review another geometry topic about similar triangles. And in this video, we're gonna actually be proving whether the triangles are similar or not. Okay. So there are three methods to proving if triangles are similar. Side, side, side is one. Side, angle, side is another. And the last one is angle, angle. Now, when it comes to the sides in similar triangles, the sides have to be proportional. Okay. And the proportions, not proportional, but rather the proportions have to be equal to one another. Okay. Because just because you have two proportions doesn't make the triangle similar. The proportions have to be equal. Okay. And as far as angles, the angles have to be congruent. There's no other way. The angles cannot be different. In order for the angles to justify whether the triangles are similar, the angles do have to be congruent. The sides, however, do not have to be congruent. They have to be proportional. The proportions have to be equal to each other. So let's go ahead and jump right in. Let's take a look at number 4. Number 4, they give us all the sides of each of the triangles. So what we need to do is see if our proportions are equal to each other. So what I'm gonna do part by part. So for example, I'm gonna if we were to actually, and for some people you may need to do this, you may need to redraw one of the triangles. So I'm gonna redraw DEF. I'm gonna put it right here. And E is gonna go at the top. This is F and this is D. And then D to F is 8. And let me use a different color. D to F is 8. E to F is 5 and E to D is 15. Now we can do part by part. So I'm gonna do, I want to have AC over EF. I want to see if that's equal to the proportion CB over FD. And the last one is AB over ED. Okay. Now we can go ahead and just fill in those numbers. Okay, so the sides that need to be congruent, or they need to be, see if they're proportional. 5 over 7 should be equal to 11.2 over, oops, wrong triangle. Let's do that again. AC is 7. 7 over 5 is equal to 11.2 over 8, which should also be equal to 21 over 15. Now, what we need to do here, you're just checking to see if these fractions or these proportions are equal. So I'm just going to pull up a calculator real quick. And 7 divided by 5 is equal to 1.4. So this one is 1.4. 11.2 divided by 8 is equal to 1.4. 21 divided by 15 is equal to 1.4. So since all the proportions are the same, we can conclude that they are similar. Okay. And they are similar because of side, side, side. Okay. All right. Let's take a look at number 5. Now, for number 5, the diagram only gives us parallel lines. They tell us that those lines are parallel. Now, I'm going to set up two different transversals. The first transversal we're going to look at is right here. So we have two corresponding angles. This angle is congruent to this angle, okay? So that's one set of angles that are congruent. Now, if we erase that and we look at this other transversal right here, we also have another set of congruent angles, which is here, okay, and here. Now, if we get rid of all of those, we can see that we have two sets of angles that are congruent, okay? And with that much information, we can simply just say, yes, they are similar because of angle. Now, one thing I did forget to do for number 4 and number 5 is write the actual statement as well, the similarity statement. So for number 5, the similarity statement here would be triangle VZW is similar to triangle XZY. Okay. And as long as you can change the order, like for example, I could have written triangle WVZ, but then I would have to say that that's similar to triangle YXZ. Okay. So you could write it that way. The order doesn't matter as long as the order for both triangles they go in the same order, okay? The same thing for number 4. Number 4, we could say triangle ACB is congruent to triangle EFD, okay? All right, and you can, like I said, if you written it differently, if you start at a different point, like say you start at B, then in the other triangle, when you name it, you would have to start at D, okay? All right, so hopefully I haven't confused anybody with that, but we just want to make sure that those two things are clear. Let's go ahead and do number 6, okay? We have 6, 7, we got to go all the way to number 11, all right? So now, with number 6, we have a set of vertical angles here, okay? So those vertical angles are right around the intersection. So this angle and this angle. So that other blue angle is also 67. Now, what we need to do is find the missing angle for the third angle for both of those. So for the top triangle, 67 plus 28, oops. That's going to be 95, okay? And then we have to do 95 from 180, which is going to give us 85, okay? So this is 85. Now, when we look at the other triangle, so this is 85 degrees, oops. 85 degrees. Now, when we look at the triangle towards the bottom, we're going to do 67 plus 82, which is 179. Did I do that right? No, excuse me, not 179, 149. And then we do 180 minus 149. That's going to give us 31, okay? So this angle right here is 31 degrees. So, are these similar? No. Okay, angles are not congruent. Remember, the angles have to be congruent in order for the triangles to be similar. As far as the sides just have to be proportional to each other. Okay, number 7. Once again, number 7, we have a situation where we have vertical angles. Okay. Now, we do have the angle part, but now we need to see if the sides are proportional. So, for example, I'll take the smaller triangle and put 8 over 10. So for the smaller triangle, I'll do 8 over 10 is equal to 12 over 15. Now, for number 7, some people could have done it this way. You could have used this other proportion. You could have used the proportion. I'm going to do the small side of the triangle. The small side of the small triangle over the small side of the larger triangle. So I could do, this could be 8 over 12 is equal to, now I want to do the large side of the smaller triangle over the large side of the larger triangle. So that would be 10 over 15. Now, either proportion, no matter what proportion I use, they should still come out to be equal to one another, okay? So if I reduce these, for example, if I did the 8 over 10, that would reduce to 4 over 5, because I could divide both of those by 2, right? Could divide that by 2, divide that by 2. And for these over here, I could divide both of these by 3. And that would equal 4/5 again. So this actually checks out, right? And if we did the other proportion, okay, now remember, you don't have to do both. You can just pick which one. I'm just showing, modeling that you can set up different proportions to see if they are similar. So 8 over 12, both of these, once again, you can divide both of these here by 4 for this one. And if you do that, that becomes 2/3 equals. And then for the other ones, we can divide both of those by 5. That's going to become 2/3 again. So no matter which way you set up your proportions, we see that both of them are equal. So we know right away that these are similar, okay? Now, the reason that these are similar, is because of side, angle, side, because the sides are proportional in one of the angles. And the angle is between the two sides, okay? So now that we've established that, we can go ahead and write out our statement. Triangle SUT is similar to triangle VUW. Okay? All right. Let's take a look at number 8. Number 8, once again, for this one, we don't have any side measures, but they gave us angle measures. So we obviously need to find the missing angles for each one of these right triangles. Okay? So for the first one, we have 90 plus 61. That's equal to 151. And then 151 from 180 is 29. So this becomes 29 degrees. Now for the larger triangle, we're gonna do 90 plus 29. That's gonna be 119. And then we do 119 from 180. That's gonna give us 61. So this is gonna become 61 degrees. Now, as we look at both triangles, all of the angles are congruent. So these are said to be similar because of angle. Okay? And our statement here, we could simply say triangle, and I'll start with the first letter B, C, D. Okay, so I went from 29 and 61 to the right angle. So I have to follow that same pattern. So 29 is G, and then F, and then E. So that's how those triangles would be congruent, okay? Well, not congruent, but similar. All right, number 9. For number 9, because we have one triangle inside of another, I would definitely suggest just redrawing them quickly. So that's A, this is E, and this is D. AD is 16, AE is 20, and then we have another triangle. And they don't have to be accurate, okay, just close to what we have. C and B. Now AC, for AC, I have to add both of those numbers. So 16 and 36, that's gonna make 52. Okay. And for AB, I have to add those two, which is gonna make 68. Okay. So now that we have our sides, remember our proportions have to be equal. So I can write two different proportions. I can either write, I can do 16 over 20 equals 52 over 68, or I could write 16 over 52 is equal to 20 over 68, okay? Either way, we want to figure out if these are similar, okay? I can reduce these. For the first one, I can reduce both of those by 4. And as a matter of fact, we can just plug it into the calculator real quick, okay? So let me slide this over. So if I do 16 divided by 20, that equals 0.8, okay? So this is gonna be 0.8. The next one, 52 divided by 68 is equal to, what's that? 7.6, blah, 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 blah. But those are they're not equal, right? So let me put the equal sign there. They're supposed to be equal, but they're not, okay? Now, like, even if we do the other proportions, 16 divided by 52, that's equal to 0.30, roughly. And if we do 20 divided by 68, that's equal to 0.29. Once again, these are not equal. So it can be said that for number 9, no sides are proportional. So this is no sides are, or sides are not proportional. Let's say it like that. Sides are not proportional. So they're not similar. Okay. Number 10. And we're almost done. Okay. So for number 10, once again, we have parallel lines. And first, let's start off by identifying our vertical angles. We have vertical angles right here. All right. Now, once again, with those, with these two parallel lines, let me draw those a little straighter. Hopefully that's better. So we have our parallel lines. Let's draw a transversal. Now with that transversal, we've created a set of alternate interior angles, okay? So those alternate interior angles are congruent. So with that being said, I can erase those, and now we've adjusted our diagram. We can automatically see that these are these are similar, okay? Because of angle. And we should be able to write our triangle similarity statement. So triangle MNL is similar to triangle PKL. Okay. And another way to try to recognize how I came up with that. M doesn't have any angle markings. P doesn't have any angle markings. So both of those went first. Okay. Then the next one was the angle with 2 markings, which was N. So MN, and then I had to have PK, and obviously L was the last one. All right, number 11. So once again, we want to just check to see if these sides, because they only give us sides. So I'm going to take the bigger triangle and the biggest side, which is 30, and I'm going to put that over the biggest side of the smaller triangle. The biggest side of the smaller triangle is 21. Then I'm going to take the smaller side of the bigger triangle, which is 18, and I'm going to write that over the smaller side of the smaller triangle, which is 12, okay? And if we need to, once again, just pull your calculator out and check the proportions. Well, for this one, we can reduce it. I don't even need to use a calculator. We'll just go ahead and reduce those. So for the first one, both of these can be divided by 3. And the other one, we can divide both of these by 6. All right, so when we do that, 30 over 21 becomes 10 over 7. That should be equal to 3 over 2, which is not. So no sides are proportional. Sides are not proportional. All right, ladies and gentlemen. So that will conclude our work on proving if triangles are similar or not. You all have a great day and see you back for the next geometry lesson. Deuces.